Okay, we return another interesting integral suggested by Sid. We have the integral of x, natural log arctan x to the fourth, plus 2 over arctan x dx. Okay, now this one seemed pretty tricky. The trouble is, it's kind of weird to have a plus sign here. It makes me think you could break it up into two integrals, but these don't look that easy if you solve them separately. So it's making me think somehow this is the reverse product rule, and we do have this connection where we have arctan here, and then we have it here. So what I was thinking we could do is, by log properties, I can actually take this 4, bring it outside of the log, and actually bring it all the way over to the x. And then what I'm wondering is just, what is the derivative of just this part? What's the derivative if we take this of natural log arctan of x? Well, first what's going to happen is we're going to get 1 over whatever this is, right? We're going to have 1 over arctan, and then we need chain rule. Derivative of this is going to be 1 over x squared plus 1. So for these to be really easy, what we hope is right off the bat for this to be like really similar. We have the arctan here, that's good, but then this x squared plus 1 is nowhere to be found over here. But then my next thought is, what if we kind of created like an x squared plus 1 so that when we do this, this would cancel. And then a constant we can always deal with later. So what I'm thinking of is, what if we look at the derivative of x squared plus 1 times natural log arctan of x. And for this derivative, what I want to do is use product rule of two things, right? So first we differentiate this first part, and we're going to get just 2x for the derivative of that, and then we just keep the second part. And then next, we'll add it. We'll keep the first thing, x squared plus 1, take the derivative of this, which we already found. That's going to be 1 over arctan x. And then times this, let's put it over here. So this is going to be x squared plus 1, but this is all one big fraction, and this is going to give me the cancellation that we wanted right here. But now let's compare this to our original integral, because we're getting pretty close. I've already moved this 4, right? So this 4 is going to come over here in front of the x. And now you'll notice that we're matching on everything except for the constants. We have the natural log tan x here, we have the x, we have the arctan x, but then this is a 2 here, and then this here, this 2 should be a 4. Well, like I said before, it's really easy to deal with constants. We can just multiply in everything by 2. If I multiply what we have here by 2, with a derivative, this can always come outside the derivative, so this doesn't complicate the derivative at all. We can just multiply in 2 on this side as well, multiply by in 2 here. And so then 2 times 2 here is 4, and this is just a 2 over here. And now what we've done is this right here, this is exactly what we have for our whole integral. So just to try to make it clear what's happening, if you integrated this on both sides, this goes away, and then our solution is going to be right here. And so for the final solution of this, we just get 2 x squared plus 1 natural log arctan of x, add a plus c, and that's it. Okay, there you have it. Thanks everyone for watching. Have a good day.